All right, I want to describe three unique graphs of f of x where the limit of f of x as x approaches c does not exist. Okay, so let us think about this. So we have a graph, let's call this c. An example where it does not exist would be an asymptote. Think about this. If I have a graph and the graph goes like woo next to that, and this side goes like boo like that, are we approaching from the left and from the right, are we approaching the same value? No, we're going completely different places. So that is one example of where the limit does not exist. Okay, another example, okay, we'll call this C, would be if I had a graph that goes la 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 and it goes there, and then another dot right here go la 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 la. All right, so this right here at C, the limit is coming this way from the negative side, and this way positive, the positive side, so the limits do not match. You're not going to the same point from both sides. So this is yet another example that of a limit that does not exist. The third one is kind of pointless. You rarely will see it, but I'm just going to mention it real quick. So if this is C, what it is there's this weird function sometimes that go real quick and then they go down. That was a terrible graph. But they oscillate back and forth so fast that there's no value there. It's like multiple values. And it's like, which one is it? When we come from left or come from the left or come from the right, we get multiple values. It's a really weird function. You will not see this one rarely ever. These are the two examples of where limits do not exist, because what you come from the left and come from the right do not approach the same point for either of these functions.